All right, you all, good evening. Good evening. We are back for another Math Mindset Reset. This evening, specifically, we are focusing on beyond memorization, right? What happens as we want the young people to think beyond just giving us back exactly what we told them. We need y'all to think, right? We need y'all to apply it. So that is what we're talking about this evening, y'all. The goal is to help educators and parents, again, move beyond the rote memorization. You're not just giving it right back to us, right? We're introducing strategies that encourage critical thinking, reasoning, and application. Very big deal, y'all. So I want you all to think, have you ever had a student or has your young person at home struggled because they aced a multiplication quiz, but then when you asked them to apply it in a real world problem, they were lost. It wasn't connecting for them, right? Y'all, because knowing isn't the same as understanding. Y'all, G.I. Joe lied. You remember G.I. Joe? They used to say knowing is half the battle. No, it's not 50% anymore. The needle has shifted. We can know something, right? But we also have to apply it. We have to be able to apply it in real time and recognize the situation as well. So, I definitely aged myself, but G.I. Joe did not hold it down on that one. They did not tell the truth. Knowing isn't the same as understanding. So, we're going to talk about how we're going to shift students from just remembering to actually thinking about it. And sometimes we're going to have to slow them down to think about it, right? So, you might be thinking, well, why now? We're halfway through the school year. Well, that's exactly why, because a lot of schools, you might be wrapping up your mid year assessments. And now you have a really updated and accurate picture of where your student stands, right? Any gaps will be revealed, and whether or not they're really understanding the concept that's happening. So, you all, it's really the perfect time to pivot instruction. It's like this sweet spot between, okay, I taught you some things, I need you to know it, some recall, but we're working towards mastery. And the test is coming up, but it's like a sweet spot before we go into hardcore test prep taking over, where we can really help deepen their conceptual knowledge so they can apply it, which all works together for life past the test, right? Beyond the test, for sure. So I want you all to tell me, what is a math concept that your students know, but they might struggle to apply? And I'll kind of tell you what I've heard most often based on the grade bands, right? So for K-12, something that parents, right, talk to me about when I'm connecting with some of their young people and educators. I'm supporting them, coaching them, things that students know, but they struggle to apply it. They struggle to recognize it in a real world situation. From kinder to two, y'all, it's basic addition and subtraction in context. So a student can say what 5 plus 3 is. 5 plus 3 equals 8. Yeah. But they might struggle, and y'all like, ooh, not these apples again. But yes, they might struggle with the apple question, y'all. If you have 5 apples and you get 3 more, right? Just kidding. How many do you have now? Some students struggle with that. They're only used to just the numbers. Understanding place value from kinder to two, that a child can count to 100, but doesn't understand tens and ones, right? Let alone getting into the hundreds place. So, another thing for kinder to two, measurement in real life. They can use a ruler pretty well to measure some lengths, but they may struggle if you're asking them to estimate some and apply it in real time. So, is this book longer or shorter than a ruler? What do you mean? Right? Y'all, third to fifth grade, some of the things, again, that students know but struggle to recognize. Those multiplication and division facts. Yes, ma'am, we can tell you forward, backwards, right? 6 times 4 equals 24. 4 times 6 equals 24. They can give you the division side of the fact family. But word problem life. If 6 students share 24 candies equally, how many does each get? Sometimes it's crickets too often in the classroom. So again, this application of it, because we're going way beyond the memorization. You are also at this age, there's a lot of ways to, a lot of strategies to really, again, teach the figure out, right? How to figure it out, even if they don't know, because that's actually life skill, like lifetime, life lesson time. That's more important. If you don't know, can you figure it out? When you don't know, what do you do? Okay, so we're coming back to that. Third through fifth, fractions as numbers. They can say 1/2 plus 1/2 equals 1 or 1 whole. But if we say which one is larger, I need you to compare 2/3 to 3/4. A wrench is thrown. Okay, area versus perimeter. We can memorize the formulas, but can't apply them in real life. Which do we need if we're talking about how much carpet is needed to cover the floor? Right? So again, way past regurgitating, way past just these simple, oh, yes, I can tell you this. You showed me that. I'm going to write it right back to you on a beautiful little note. No, we have to apply it. You all, assessments, questions, assignments have not looked like straight calculation in a very, very long time, in some decades now. So we have to change it up, level up how we're presenting it at home, how we're helping them practice at home and in the classroom. We're going up through the grades, y'all. So 6th through 8th, we're talking about concepts that students know, but they aren't applying it. They aren't able to. So middle school life, 6th through 8th, y'all, that's ratios and proportions, negative numbers, linear equations. So same thing. They know that a ratio, they can set it up. 3/4 equals x/12. But if a student is asked, okay, this recipe calls for 3 cups of flour for 4 servings. So how much flour is needed for 12 servings? Whoa, what? What just happened? You rocked their world. Negative numbers in context. They know all day. -5 minus -2 equals, but if we say, okay, woo, look in Alaska right here, the temperature was -5 and they said it's going to drop 2 more degrees. Ooh, how cold is it going to be? What? Right? So these are the conversations, because it's not straight. Again, it has not been straight calculation in a long time. I'm going to say it again. Y'all, G.I. Joe said, knowing is half the battle, and they lied. They did not tell the truth. We're way past knowing is half the battle. You have to apply it, and you have to recognize when to apply it. High school, we're talking about percentages in context. The quadrilateral, y'all remember that, right? Some of y'all might have had a flashback. The quadrilateral, or the quadratic formula, rather. Maybe you remember and can understand and solve x² minus 4 equals 0. But how would you apply this to throwing a ball in the air? What does the quadratic formula have to do with throwing a ball? Y'all like, nope, right? Probability in real life. High schoolers might know, okay, if a basketball player makes 60% of the shots, I can understand that they're more likely, right, to make the shots. I can write it as a decimal. I can write it as a fraction. We'll say, okay, well, how likely are they to make 3 in a row? What? Y'all, this application piece is necessary, and it's real life. It's regular life where you can answer some of those why type questions for young people, right? So not just saying that we're just throwing memorization all the way out the window, because it's useful, but without deeper thinking, it often falls apart. When it's time to solve the problem, I don't even know what to use right now. So memorization cannot be on an island, right? We have to make sure we have deeper thinking. So that student memorized 6 times 7 equals 42, but then each table seats 6. How many tables are needed for 42 students? Did they recognize it? Could they apply it? So some of the shifts we need to make, instead of saying, well, what's the answer? Ask them, how do you know? Right? Rather than just checking on their multiplication, checking their division, can you show me another way? Right? Share your strategy. Think out loud. These are some of the things. Instead of solve for X, again, how many different ways can you show me to find this answer? Can we use a picture? Can you create a model? Fun fact, a lot of the young people these days are visual tactile learners, we call it, right? A lot of us, we didn't even know our learning styles growing up. But most educators for sure, and I know a lot of parents are locked in, and you know your students' learning style. Most of the kids fall in visual tactile, meaning they need to see things and they need to do it, and that's what helps them grasp, right? A lot of them are combinations at this point. So the more visuals, the better, but they still have to do it. What's the formula for area? No, instead we can say, how can we figure out how much space this rug covers without memorizing a formula, without using the formula, right? Maybe they're estimating with counting tiles, maybe they're using other objects to kind of lay out. So lots of ways, y'all, lots of ways. So we also want them to deepen their thinking, to deepen their thinking by explaining their reasoning. So at home, it might go something like this: some math talks during dinner time. Yeah, we're posing real world questions. Now, listen, I know some of y'all like, look, it's dinner time. We're hungry. We don't have time. Maybe take a couple bites first, eat a little something, something, take a couple bites. Then, we took the edge off. We can talk a little bit. So, real world scenario: if we split this pizza into 8 slices and we eat 3, what fraction is left? Yeah, we talked about for the different grade bands, things to focus on: the 3 to 5, multiplication, division, and understanding fractions. So the more they can see it and practice it, the better, for more progress, I assure you. Maybe we need to encourage some mathematics storytelling, we call it, right? Where you're explaining, you having your child at home explain a problem. How did they solve it? Tell me how you figured that out. Can you pretend to be a detective? So just, making it fun, just making it more fun, where it's not just, and I'll say this, where it's not just you asking them the same way every time, because yes, it's consistent, but it's boring. And we don't want to do that. Okay. All right. So in school, educators, we might be showing a pattern, whether it's a pattern of shapes, a pattern of words, obviously numbers. What do you notice? What do you wonder about? So that's when they're able to think more deeply and describe what they actually see. So you're also getting into them being able to prove and show their evidence, right? Also in school, probably the most underrated strategy in the game, especially for math: error analysis. Okay, so give a word problem. It's already solved out. Where's the mistake? How would you fix it? Analyzing the different types of errors, right? Sometimes they make a mistake with their calculation. It's like, okay, they understood what to do. We just messed up multiplying right here. We messed up on the division. Sometimes they don't understand. So that's a conceptual error. They don't know what to do. Okay. So not just having them interact with problems that are solved and solved incorrectly on purpose, but still as a class, still as a group, still as the educator, you still going back to see what types of errors are they making. Because it may not be, okay, we have to reteach the whole lesson. No, they understand what to do, but we have a few people making some division errors, right? So the power of really reflecting on the error, the type of error, and checking for accuracy. Yes, yes, yes. So someone said, I love using feedback codes for this. A, check for accuracy. Yeah, just writing it directly on their papers. There's lots of, we have a very specific talk we're going to have soon. We're streaming live because, again, error analysis, I think, is severely underrated, underutilized. So we're going to talk about it, y'all, because there's some ways to jazz it up, right? With color coding, small group, whole group, lots of things to discuss. So we will soon. I promise. I assure you. Listen, a lot of us have a million and one things that we're doing all the time. So also when you're out and about, what are some of the ways we can incorporate some of these things to make them think deeper? Not just, okay, do you know that fact? Great. Is this area a perimeter? Great. No, we're thinking more deeply. Now, some of y'all might say, well, Anika, you have a shopping problem because you were talking about shopping last time. Listen. I might be at the grocery store. Y'all don't know. Okay. But we can do some estimation games, right? We can estimate the total cost. And every now and again, bring some cash. I know the cashier might give you the stink eye. I know, but bring some cash. So still the estimation for the change can happen too. Well, this is how much you think it's going to cost. If I pay with the 20, how much am I going to get back? Unit rate. Listen. Everyone should be locked and loaded for this unit rate. I've seen a lot of conversation, I'll say, as people are shifting from smaller grocery stores to warehouse like Costco and things. You still need to be checking the unit rate. Okay. Because yes, it's a bigger package, but bigger does not always mean better. You still need to find out if you're getting this 24 pack of toilet tissue, but at a smaller store, it's a 6 pack. What is the cost per roll? What is the cost per roll? You still need to do some math, because just because it's bigger, people assume, oh, that's the better deal because I'm getting a lot. You're paying $55 for it though. Okay. So you have to do the math. That's called the unit rate. So they can use the calculator on their phone, on your phone for that. But that's something to do real time, that comparison price shopping. Also, how many of each will we need? Y'all know the ever popular hot dog bun situation. Why do they not come in the same quantities? I do not know. I'll never know, right? But that could be a real world problem. Okay, well, we have 20 people coming over for a little gathering. We're gonna buy. We want everyone to have at least two. So first, how many hot dogs are we gonna make? Okay, how many packs of hot dogs do we need to buy? How many packs of hot dog buns do we need to buy? Because it's not going to be exactly the same. It's not. All right. Some other things. Maybe we're in the car, right? Because we're on the go a lot. We have a lot of things to do. So if we have 35 miles left and we drive 7 miles every 10 minutes, how long will it take us to get home? Ooh, right? What if we're doing and practicing skip counting for some of our younger? We want them to know how to skip count by 5, by 10, by 2, a lot of different things. Every red car you see, we're counting by 5. Every blue car, we're counting by 10, right? Y'all just helping them just practice and see that you can practice math and talk about math in any setting, anytime. I'm always going to say the more hands-on, the better. And it doesn't matter if it's for the kinder to third through fifth, sixth through eighth, all the way up to high school, right? The more connections, the better. So especially when they're first starting to learn about numbers and interact with numbers, there tends to be lots of manipulatives, right? Lots of hands-on stuff people know to do. However, when people start to get just a splash older, when they get to third, fourth, and fifth grade, it tapers off some when they aren't interacting with math by touching the manipulatives at first. We just like to jump to drawing the pictures and solving the problems. And it continues to fall off for middle school and then high school. You all, there are manipulatives for every stage of math, every age, every stage. And so that's where we should start. So thinking about for middle school, where we say it starts to taper off some. So we still can use fraction circles because we're talking about proportions, which are just equivalent fractions, right? We can use a map, the scale model, right? Because that's just proportion, right? Or they shrunk it down to this size, an inch represents 50 miles. So you let them touch and see and interact with as much as possible, right? And I'm gonna keep saying shopping and money for a lot of high school examples. Y'all, really quickly, I want to ask you, what's a question that you're like, okay, we've talked about some things. What's a question that you can start asking your young person or your students this week to push their reasoning? What's a question? While you're thinking about it though, I'm going to give you some of the goals of the questions. So maybe we need to do it oppositely. Maybe I'm going to give you some of the goals of the question that'll help you choose your question. So if we're asking, educator side first, if we're asking, what do you notice and what do you wonder? We're encouraging their curiosity. We want them to think about it before they just jump to solving. So that might be the question for the students. We need to slow down. The students that hyper focus on the numbers, right? They might circle them. They just start doing stuff, but they really didn't take in the context of the problem. If you ask, what would happen if we change the number? I want you to analyze some patterns. I want you to analyze and check out the relationships between the numbers. Yeah? Maybe if you ask, can you teach this to someone? The students have to assess themselves. Do I know this well enough? Do I know this how I'm supposed to? Right? Classroom life, educator life still, if you ask, okay, y'all, so how does this connect to what we talked about last week, what we learned last week? Students see the bigger picture and make those also powerful connections because math is nothing but layers of information, right? Third grade builds on second, fourth builds on third. So it's just a little added layer each year, okay? If you ask, if you didn't have a calculator, how would you solve this? It makes them lean back into and tap into their number sense. How well do they understand the place values, right? And how the relationships work between multiply and divide, add and subtract, multiply and add, subtract and divide, okay? It makes them tap back into those basic number sense things. Parents at home, I'll give you some questions. I'll give you the results also for you to marinate and ruminate on. So if you ask, how could you figure that out? It helps them practice their explanation rather than, all right, I got 5. Boo hiss. Explain to me how you got it. How did you figure that out, right? Also, parents, if you're asking, could there be another way to solve this? It encourages flexible thinking and creativity. I know sometimes people kind of pause when they hear, right, the math consultant, math teacher talking about creativity, but creativity is essential for problem solving. You have to be able to see and understand multiple perspectives and not necessarily only one way to get it done. So, yes, they go together. Now, what part was the hardest and why? Again, has them self-reflect, right? Has them self-reflect not just what was the hardest, but also why. Like, oh, you know what? That part was a little hard because I know I don't know my 9 multiplication facts as well. Y'all, that's powerful. Powerful. Last one for parents. Where do you see this math in real life? And really, listen, we want to say that as much as possible in the classroom as well. I always will talk about how, some teachers are like, oh, kids always asking, when are we going to use this in real life? I'm like, start your lesson off differently. Start the lesson off with the real world connection. What if we were trying to figure out the shortest way home, right? I have to walk 2 blocks this way, 4 blocks up, but there's also a park I could cut through. Y'all, that's Pythagorean theorem. So if you launch your lesson, again, with those real world connections, so like in class, right? Then at home, we're connecting math as much as possible to the daily experiences. Listen, we have a whole generation of deep thinkers and mathematicians out here. And that's the goal. That's the goal. It really is. Okay. So, okay, yes, we're going to talk about AI. I'll say, I know some of y'all are like, boo, what the world, right? I know there's 2 camps. People are either with it or they're really, really not. I will say that AI can support deeper learning, especially in math. So before we talk about it, let me give you this perspective. So a couple months ago, right, I was really observing more of a debate where people were talking about exactly this. Like, should AI be this locked in? Should it not? People are going to get more lazy. People aren't going to be as intelligent, and thinking how we want. So just all the things, all the things I'm sure you all are very aware of. Someone in the debate contributed this. This person said, so do you all know that Socrates, Socrates, like the Greek philosopher and all that, right? So Socrates was against books for the very same reason. I was like, what? That seems crazy, right? That Socrates was like, when people don't have to memorize things anymore and internalize it and apply it for themselves, they're just going to be able to flip and find the answer. People are going to get unintelligent. People are going to get lazy. So with that perspective, I said, but think about how much more knowledge acquisition has occurred because of books and people being able to apply things or get the answer they need to apply it to these different levels and tiers of questioning. I thought that was really interesting because I did not know that. So, I looked it up and stuff later, and yeah, it's, in certain spaces it's common knowledge. So I thought that was really, really interesting that that all those years ago, the very same argument against books is what people are saying against AI right now. I thought that was really, really interesting. Okay. So someone said, students doing well have said to me, but it's going to be harder next year. What is just a splash though? Just a splash. And that's why we get the foundation tight this year. So you're super solid and you just continue, just add this little layer right next year. That's it. That's it. It helps them keep their anxiety in check about what's to come. Yes, and I will also say that sometimes the adults need to rein it in as well, right? Because when you get to middle school, because when you get to high school, right? And so that does build up. The kids might play it cool, but they're freaking out. They're freaking out inside. So making sure that the adults, we aren't overselling it. I'll say, yeah, it's going to be a difference. Yeah. But it doesn't have to be extremely hard or difficult or anxiety producing. It doesn't have to. All right. So a couple notes specifically on AI in math. So there's this thing a lot of platforms use. It's called adaptive questioning. And so if you're familiar with like your student taking like the MAP test and things, because it's not like an end of the year assessment to say, hey, what did you learn in third grade or eighth or 10th? But it just gives them questions in the categories, right? We talked about our math categories. And if they're doing well and getting them correct, it keeps leveling up. It adjusts, it adapts to what they're understanding. So that's why you might have young people that are in second grade, and in number sense, they might score more like a fourth grader or a fifth grader, because it just lets them go for what they know. So that's some of the ways that, again, even understanding that with the adaptive questioning, we can tap into students what they are strongest in, right? And use that to help them where they need the most development, right? By making those connections, but first being aware of it and making those connections, and AI can do it quickly, just providing that summary, I'll say. Right. So different solution paths. If we're asking the young people, okay, well, what's another way to solve it? And what if they're not sure, they can ask, right? And they can get some specific examples for their problem. Maybe they can do a table, a graph for this one, or here's the linear equation for that one. So here's the verbal statement, right? Just multiple representations. The more exposures and interactions that they have, it really, really locks it in. Very much so. Again, instant feedback. Now listen, teachers work hard and teachers are great and teachers are professional. But that instant feedback, we do what we can. But imagine 26 people and they all click submit at the same time. AI can kick it right back to say, okay, and also communicate to the teacher. We talked about that summary piece being big. We talked about the type of errors earlier. So letting the student know if it was a conceptual error, a computational error, and then also compiling all of that data for the teacher as well, right? For the teacher as well. For each period, for first, second, third, A day, B day, whatever you have, it lets you know in real time quickly, and you're able to analyze the trends, because maybe the middle of the day, maybe I taught it a little differently because that whole block got it, that group of kids. So that first period, let me go back and see something. Let me go try more what I did for the last classes, because first period missed it. Okay. Right. Someone said trying to give 34 students immediate feedback. Their teachers are human. AI is not. So the humans leverage the tech to be even better. That's the goal. That's what we're doing. Okay. So y'all, just to wrap up, like I went on a little bit of a tangent, but it was important. It was important to say. To wrap up, we understand that memorization is a starting point. It's not the goal. We start there. We're not going to stay there, because nowhere in their life, in their space, assessments, tests, and be real, in your life, you had to do more than just know something. You had to apply it. You had to recognize when to apply it. So we talked about these simple shifts in questioning. Lots of question information this evening. Simple shifts that can boost reasoning because we want them to think, we want them to justify, we want them to explain. And AI can be a powerful tool, not the end all be all. Again, a starting point, a powerful tool as we encourage them, support them in their critical thinking. So, again, coming back to it, was one strategy, was one strategy or one question that really resonated with you from this evening, and you would try it this week, right now, ahora, right? What is one question, one strategy that resonated with you this evening that you're like, you know what? I can try that tomorrow. I can try that on any day this week. All right, let me know. All right, giving y'all some think time. Right, maybe you decide to swap out some of your multiple choice questions for open ended, where you're asking them to explain how they would solve it instead of solve it. Maybe maybe you're going to start asking why more often. And I'm laughing because to know me, you know that that is my favorite question. Like probably in too many spaces, honestly. Like why? Why did you think that? Why did you, arrive at that? So why? And it can really, literally that, just why? Well, I think the answer is 10. Why? Well, because I used a graph. Okay, well, why did you decide to use listen? And you know that, y'all know that from when kids are little, right? When they're toddlers and they're just repeatedly asking why, and it's like it'll never stop. You make sure you make it stop. But you can ask why indefinitely. Okay. So, yes, feedback for each period, for each child, definitely very effective. An effective way to use AI. Educator life, maybe you're going to incorporate more real world problems in your lessons. And again, I'm going to say at the beginning, when you're trying to grab their attention, that hook, put the real world problem, the real world situation in the beginning. Error analysis, listen, not to be, not to try to persuade, right, your decision, but hey, error analysis where students find and correct the mistakes instead of just solving the problems. And depending on their age, they love it because they love to find where you messed up. Do you know that? That they love to figure out where you messed up, or they always have, it's a certain like upper elementary, they always want to be the teacher and in that teacher role. So that's a way for them to do that. Oh, well, this right here, because you were supposed to, and so they are explaining, right, the error and what they need to do to correct it. They love it. Love it. Parent side, I'm going to ask my child to estimate the total before we check out in the store. At dinner, I'm going to ask my kids some math questions based on what we're doing, or even during dinner prep, right? Some of the fractions, if we're measuring, using measuring cups and things. Parents, I'm going to encourage my child to teach me how they solve their homework problems. So walk me through it. And I'll use math talk during playing, maybe just counting blocks or sorting objects, right? Even in odds, groups of 3, groups of 4. Yeah, there's so many things to do. I cannot wait to hear about what you decided to do, which type of questions, which tasks and activities. A lot of information, a lot of good options. Please do make sure that you visit our link tree in the next day or two, because we're going to have some resources up there closing out January, right? The test anxiety bingo boards are up, and we have some new things that we're working on for the end of February, right? Actually, I'm going to go ahead and tell y'all. I'm going to tell you. So it's an educator's assessment toolkit, but it leverages AI. It gives you some strategies to how to use AI for what, right? Not violating FERPA, promise, but also including some prompts. So these are some challenges, some tasks, and some things that you can have AI create. But guess what? Did you know that if you ask AI what are some things that they can't solve, it'll tell you? It's like, oh no, I can't do those kind of problems. So just something to keep in mind and something to be watchful of and mindful of. Again, coming out later on this month, this February, okay? So thank you all so much for joining. Love the conversation, the discussion. Thank y'all for y'all's engagement. And I will see you next time as we move beyond memorization and start building thinkers. All right. Bye-bye.